All right, we got another challenge problem here. So this one check to see if you can draw some position time graphs, velocity time graphs, and do some kinematics equations on top. So here's our scenario. A dragster accelerates down the track at 12 meters per second squared. After it completes the 8.16 second long race, it takes another 10 seconds to slow down to a complete stop. Your job is to determine the max velocity of the car and the total distance it traveled all the way from start to stop. And again, you got to sketch a VT and XT graphs if you want full credit. So behind all these boxes are the answers. So I shall reveal them to you after you give it your try. So pause this video, do your best, and forget the rest. See you in a few. All right, I assume that you've paused the video by now, and if you're still watching this, then pause the video. Here are your answers. Let's go through them. Here's the final answer for the distance. Booyah! Here is your graph. Ta-da! And then here's me working through some math. So let's see if you got all the same stuff I got. So I kind of broke it up into race and then braking information. So first I'm going to go through the graphs. You start from rest at the race, then you race, you're always moving in the forward direction, you eventually reach your maximum velocity, you hit the brakes, and you're going to start slowing down. Then, for the position time graph, since you're speeding up, you've got an exponential curve here. As your slope gets steeper and steeper, you're going faster. Then at this point, you're at your max speed. You're going to start applying your brakes, get slower and slower. Eventually, the tangent line or the slope right here would become 0. So these are your graphs, is what they should look like. Now, I didn't use my graphs. You could have used the VT graph to help solve some of these problems, but I just used straight up kinematics. So I listed all my information for the race. I knew my initial velocity was 0. I knew the acceleration was 12. I knew the time interval was 8.16 seconds. And I was looking for not only how far it went, but the max speed. So here's me choosing the equation that has all the elements for max speed in it. I basically subbed, I solved, I got the max speed of 97.92 meters per second. You know, hey, what's realism? And then I just threw some numbers in. What do you want from me? And then we've got a displacement here to figure out how far it went. And all of the variables gave me the 1/2 AT squared equation. Subbed, solved, got 399.5 meters as the first part of the race. Now I had to break this up into two parts because there were two different slopes, so I have two different accelerations, so I always have to use two different equations. That's a big mistake people use, is they'll just say, oh, I went from rest to rest, and they assume it's just one thing. But if you ever have two slopes on a VT graph, you're going to need two different equations. Finally, while braking, I now knew my max speed, so I just took that as my initial velocity. And then I said, well, the time was 10 seconds to come to a stop. So my final velocity was 0. I'm looking for displacement. This time I got to use the 1/2 equation, or again, area of a triangle. And when you do that, you get another 489.6 meters. So if you want to figure out the total distance, you have to add the racing distance to the stopping distance, and you'll get 889.1 meters total. So if you found that to be highly doable, then I think you're in a good spot for the assessments. And if you're having trouble, again, check out more videos or come see me, and hopefully we'll get that fixed. As always, enjoy some science.